Edexcel IAL Mathematics Mechanics M1 January 2023 past paper will be discussed in this video. See the description of this video. There the timestamp is given. By using the timestamp you can go to a particular question in this paper. Also by using the playlist of this channel you can navigate to any video related to physics or mechanics, mathematics. So by using the playlist you can navigate to any units in physics or mathematics, mechanics. Okay, so the first question, January 2023, mathematics, mechanics M1. A train travels along a straight horizontal track between two stations A and B. The train starts from rest at station A and accelerates uniformly for t seconds until it reaches the speed of 20 meters per second. The train then travels at constant speed of 20 meters per second for 3 minutes before decelerating uniformly until it comes to rest at station B. The magnitude of acceleration of the train is twice the magnitude of the deceleration. Okay, so on the axis below, an empty axis is given, y-axis is named speed meter per second, x-axis time seconds given. On the axis below, sketch the speed time graph. Okay, so first we will sketch roughly. So this is the given axis. So this is the speed. So initially it's accelerating for time capital T. So during that time it's traveling, its speed becomes 20 meters per second and the time taken for that is t seconds. Then it's traveling for 3 minutes, means 180 seconds at the same speed. So the graph should be horizontal. Then it's decelerating such that the magnitude of the acceleration of the train is twice the magnitude of the deceleration. So the acceleration magnitude is more. So the deceleration is less. So it will be, slope will be less slow. So we'll take, it comes to rest. So this is, it's traveling for 3 minutes. So t plus 180 seconds. And the total time taken for the journey, let it be t1. Okay. So when we draw the graph, we have to replace t1. I roughly drew it this one, t1. So we say that this deceleration is, acceleration is twice of the deceleration. So A is equal to, okay, so this acceleration, the gradient, that is 20 minus 0 over t minus 0, that is 20 over t, right. This acceleration here, that if I say A1, that is 20 minus 0 over T1 minus T plus 180, the gradient. Is it? Deceleration, but I am taking the magnitude, so that's the reason I took it 20 minus 0. Normally it should be 0 minus 20, then you will get negative. Negative means it's deceleration, but I dealing with magnitude, so I did it other way, 20 minus 0. Okay, now the question paper says that this acceleration is twice of that one, so A is equal to 2 times A1, that's given in the question. So 20 over t is equal to 2 times 20 over t1 minus 1t plus 180. Okay, so now solve this one. So 20 over t, so okay, 20, 20, 40, so 1 over t is equal to 2 over t1 minus t plus 180. Okay, cross multiply, so that will become t1 minus t plus 180, not 80, 180. 180 is equal to 2t. Okay, we'll find the t1. So t1 is equal to, take it to the other side, minus t plus 2t, 3t, minus 180, so plus 180. So this t1 should be, now we can replace 3t plus 180. Okay, so this is the graph with the values, the time in terms of capital T, right? So they asked to draw on the axis below, sketch speed time graph, means you have to put the time correctly here, which is 3t plus 180. Okay, B part, find the value of capital T. Okay, so they are saying the distance between A and B is 4.8 kilometers. Okay, so find the distance between A and B, kilometer they have given. The speed is given in meters, so 4.8 kilometer could be converted to meters. We know area covered by the graph and the time axis. There are only two properties we use in speed time graph. First property, I already used it. The gradient gives the acceleration. And the area covered by the graph and the time axis. Normally we call area under the graph, that gives the distance traveled. So we'll find the area under the graph, that is equal to 4.8 kilometer converted to meter. So it's a trapezium. So that is a B part. Area covered by the graph, that is equal to half into addition of the parallel side. So this is 3t plus 180. This is t plus 180 minus t, that is 180 into the height, the perpendicular distance between the parallel sides, that is 20. That is equal to 4.8 kilometer, means 4,800 meters. Okay, solve this, you will get the value of t. Okay, solve this. So anyway, this is 10. So that half into 20, that is 10. 10 divided by the 480. So 3t plus 360 is equal to 480. So t will be 480 minus 360 is 120. 120 divided by 3, 40 seconds, or 40. The unit is seconds. Yeah, they have to find the value of t, so 40 seconds. Okay, C part, find the acceleration of the train during the first t seconds. So that we need to find the a. So a is equal to 20 over t. So C part, a equal 20 over t, that is 20 over 40 half meter per second square, or 0.5 meter per second square. Decimal points, yeah, little thin pen. Okay, right, that's all. Okay, second question. Two particles A and B are moving in a straight line in opposite directions towards each other on a smooth horizontal surface when they collide directly. Particle A has mass 3m kilogram and particle B has mass m kilogram. Immediately before the collision, both particles have a speed of 1.5 meter per second. So they are moving in opposite directions. So this is particle A, which has mass 3m kilogram, moving at a speed of 1.5 meter per second. Particle B, which has mass m kilogram, that also has the same speed, 1.5 meter per second. This is before collision, B dot C dot, right. Immediately before collision they have speed, I wrote it. Okay. Immediately after collision, the direction of motion of A is unchanged, and the difference between the speed of A and B is 1 meter per second. Okay. So after collision there is no change in B, the speed of B, there is no change. B also has to move in the same direction, because they are saying immediately after collision the direction of motion of A is unchanged, means after collision A is going to move towards right. So after collision A will move towards right. If I say the speed is V1, this is 3m kilogram. After collision B also should move towards right, because B can't pass through A to the left, is it? B can't pass through A to the left. So B also has to move same as the direction of A. So after collision, B also should move towards right. The speed will say V2, that is m kilogram after collision. But also they are saying that the difference between the speed of A and speed of B is 1 meter per second. That means the difference between V1 and V2, 1 meter per second. Which one could be bigger? V1 minus V2 1 or V2 minus V1 1? Actually V2 minus V1 is equal to 1, because if this speed is greater than this, immediately after collision, this we are drawing immediately after collision, again there will be collision if this speed is greater than this speed. So this cannot be greater than this one, so certainly V2 will be greater than V1. So I can say V2 minus V1 is equal to 1. Okay, that is one of the information given. Okay, so A part, first part, find the speed, um, the speed of A immediately after collision. So we need to find the speed of A immediately after collision. We need to find it now. We can use the law of conservation of momentum. So we use the law of conservation of momentum. So we lose it towards right because after collision they all are moving towards right. Any direction I can use, but I'll take it towards right because anyway most of the velocities are towards right. So before collision 3m into 1.5. This is opposite direction. So minus m into 1.5 equal 3m into v1 plus m into v2. But v2, the question is they asked to find the speed of A immediately after collision. So I need to find v1. So I can write in terms of v2 could be written in terms of v1. So v2 is equal to 1 plus v1. So I can replace this as 1 plus v1, is it? So this I'll replace it now. So v2 I can write 1 plus v1. Okay, so now all the m will get cancelled, right? So that is 3 into 1.5, that is 4.5 minus 1.5 equal to 3 v1 plus 1 plus v1. Okay, so solve it. So 3v1 plus v1, 4v1 is equal to 4.5 minus 1.5, 3. 3 minus 1, 2. So v1 is going to be half or 0.5 meter per second. That's the answer. v1 is equal to 0.5 meter per second. That is the answer for A part, first part. So A part, first part, I did it. A part, second part, they are asking to find the speed immediately after collision, the speed of V. So V, we know that V, which is V2 equal 1 plus V1. So 1 plus V1, V1 is 0.5. So that is 3 by 2 or 1.5 meter per second. That's the speed of V immediately after collision. Okay. Find in terms of M the magnitude of impulse exerted on B in that collision. So earlier my other videos related to M2 I put it there. I already explained that during collision both experience the same magnitude of force for the same time period. The reason Newton's third law, during collision A exerts force on B, so B will exert the same force on A, both will have the same magnitude for the same time duration. So only thing they will be in opposite direction. So both will experience the same force for the same time period during the collision according to Newton's third law. So if this is A, this is B, A exert force on B, so B will exert the force on A, same opposite direction, same magnitude. That happens for time t, the contact time during collision is t. So for one of it, if I think about the Newton's second law, if we equal ma, that is m into A means v minus u over t. So that's going to be ft equal mv minus mu. So mv minus mu is called change in momentum. F is a vector, t is a scalar. When you multiply vector by a scalar, you will get a vector. So this vector f into t is called impulse. So direction of impulse is always along the direction of the force experienced by the object. So the impulse direction of B is towards right. Impulse direction of A on A will be towards left. Both impulse will have the same magnitude because both have same force according to Newton's third law for the same time period they experience. That is equal to change in momentum. Okay, remember that direction of change in momentum is always along the direction of the force, or direction of change in momentum is always along the direction of the impulse. For B, the change in momentum is towards right because the impulse on B is towards right. For A, the change in momentum is towards left because the impulse is towards left. Both will have the same magnitude of impulse, or I can say both will have same magnitude of change in momentum. So here they ask you to find in terms of M the magnitude of the impulse exerted on B in the collision. So if I find it for A also, you will get the same answer. I'll do both. You will see the both answers will be same. So C part, I'm going to write it for B, because the question is impulse exerted on B. So for B, I am writing. But if I write for A also, the final answer will be the same. For B, impulse I is equal to general equation mv minus mu. So according to this diagram, the direction of impulse will be towards right. So m, mass of B is m. The velocity after collision, that is v2, v2 is equal to 1.5. 1.5 minus m into u, the initial velocity is towards left. So minus 1.5. I think v2, sorry, I made a is, yeah, that is yes, so that will be correct. That is plus minus minus, so 1.5 m plus 1.5 m 3m. So the impulse experienced by B during collision is 3m. That's the answer for the C part. But if you do it for A also, not necessary, just I'll check it. For A, if I do it, you will get the same answer. For A, if I use the same equation, I equal mv minus mu, the impulse experienced by A is towards left. So the mass of A is 3m. So velocity is towards right. I am using towards left because impulse experienced by A is towards left. So 3m into the mass is, this is a general equation what I wrote. So actual mass is 3m. The final velocity is for A towards right, v1. v1 is equal to half. So 0.5 minus 3m into u. The initial velocity is towards, okay, that also I made a mistake, that is minus 0.5. So here there should be minus because the velocity of A after collision is towards right. I am using towards left. So minus 0.5. This minus I wrote it, 3m into the initial velocity, that also towards right, but I am using towards left. So minus 1.5. Okay, solve it now. That is 3m into 0.5, so minus 1.5 m plus 4.5 m. That's going to be towards left 3m. 4.5 minus 1.5, 3. So you will get the same answer. The magnitude is the same whether you do it for A or B, but they asked for B, so I did it for B. That's the actual answer, but this also correct, nothing wrong because both experience the same impulse. Okay, question number 3. A particle P is moving with a constant acceleration of minus 4I plus j meter per second square. So that is A is equal to vector minus 4I plus j meter per second squared. Okay, at time t equals 0, P has a velocity, that is initial velocity. P has a velocity of 14I minus 5j meter per second. Find the speed of P at time t equal 2 seconds. So it's a constant acceleration. So we can use V equal, we can use the equation V equal u plus at. Okay, so the initial velocity is 14I minus 5j plus acceleration minus 4I plus j times 2 seconds. When t equal 2 seconds is the speed they asked. We'll find the velocity vector first. So solve it. 14I minus 8I. So it's going to be 6I minus 5j plus 2j. That's going to be minus 3j meter per second. So this is the velocity vector. But the question is about the speed. You know, speed is the magnitude of velocity. So the speed is equal to, that is square root of 6 squared plus minus 3 all things squared meter per second, the numerical value or the magnitude. So you will get 6.7 meter per second. Right. That's the answer for A part. Yes, B part. Find the size of angle between the direction of I and the direction of motion of P at 2 seconds. So we know the velocity vector. So weak part, the velocity vector we know that. So the velocity vector shows that at 2 seconds 6I minus 3j. So that means in the direction of I, the magnitude is 6. The direction of negative j, the magnitude is 3. So the resultant velocity will be along this way. This angle theta. So if I consider this angle theta, this is the actual velocity. So this is 3, this is 6. So tan theta 3 over 6. Opposite, that is 3 over adjacent 6. So that is tan theta equal to half. That is theta you will get. Sorry, I think that is velocity. Yeah, that is theta you will get 26.6 degree. 26.6 degree. So that's the value of theta, 26.6 degree. But the question is about find the angle, size of the angle between the direction of I and the direction of P at time t seconds. So if normally we measure the angle in anti-clockwise direction. So this is the direction of I, this is the direction of velocity. This angle is 26.6 degree, means if you find this way, so the angle of V from I, the direction of I, that is 360 minus 26.6, you will get 333.4 degree. If you give it 3SF, 333 degree. Okay. Okay, now part C, question number 3. At time t equal capital T seconds, P is moving in the direction of vector 2I minus 3j. So they are giving the directional vector of the motion, that is directional vector of the velocity is given as 2I minus 3j. So that is, we can write this 2I, the directional vector of the motion, that is directional vector of the velocity, directional vector of the velocity at t equal capital T is given by 2I plus 3 minus j. So that is minus 3j means 2I plus 3 in minus j direction. So that means 2I, that is I this direction, I direction 2, minus j direction 3. So the direction, actual direction is along this way. This is the actual directional vector. So if I consider actual directional vector as this one, and if I take this angle theta, tan theta is equal to 3 by 2. Okay, so how to handle this type of question? Directional vector of the motion, that is directional vector of the velocity is given, right? I can find the angle by using calculator, right? Now, we can find the velocity vector at time capital T by using V equal U plus AT. V equal U plus AT. We are going to find the velocity vector at time T. So the initial velocity is 14I minus 5J plus the acceleration is minus 4I plus J times T. So combine I and J separated. So it will become 14I minus 40, 14 minus 40 into I, that is plus J. So T minus 5J. Okay, so here the directional vector is in terms of minus J. So we'll rearrange it that way. Along minus J, if I consider 14 minus 40 I plus 5 minus t minus j vector. Okay, so this is the velocity vector. By using the velocity vector for any vector, we can find the direction. Say for example, if there is a vector r equal ai plus bj or plus minus j, the meaning of it, along the I direction, the magnitude is A. Along the minus J direction, magnitude is B. So, to find the direction of the vector R, that if I say alpha, alpha is equal to, or tan alpha is equal to opposite, that is B over A. So, we know the velocity vector. So, we'll find the direction of the velocity by using the velocity vector. That direction should be same as this direction, because this is the directional vector of motion, means that's the direction of the velocity. Motion means motion is always along the velocity, right? So we'll find the velocity vector. So that means along I direction 14 minus 40, along the minus j direction that will be 5 minus t. So velocity is along this direction. If I say this angle alpha, so tan alpha will be equal to y, 5 minus t over 14 minus 40, that is equal to tan theta equal to 3 by 2. Okay, so 14 minus 4, here 2 we can divide by 2. So 5 minus t over 7 minus 2t is equal to 3. Now cross multiply, 5 minus t is equal to 21 minus 60. Solve it. So 60, when you bring it to the left, it will be 5 plus 60 minus t, 5t is equal to 21. Go to the other side, it will become 16. So t will be 16 over 5. Yes, t will be equal to 16 over 5, that is equal to 3 by 2 seconds. 3 by 2 seconds. Okay, question number 4. This diagram is given. Branch AB of length 1.5 meters rests horizontally in equilibrium on two supports. It's at equilibrium, so resultant force must be equal to 0, and also moment about any point, the total moment about any point equal to 0, we can say that way, or about any point total clockwise moment equal to total anti-clockwise moment about the same point, right? That must be satisfied if the object is at equilibrium or rest. The two supports are at point C and D, where AC 0.24 and DB 0.36. When a force of 150 Newton is applied vertically upwards at B, the branch is on the point of tilting about C. So that means when a force of 150 Newton is applied vertically upwards at B, it's at the point of tilting about C. So that means we assume the branch is at horizontal position, but no contact with C. It's little bit moving up, and it's losing contact with D. So the normal reaction at D will become equal to 0, but there will be contact with the C, but AB remains in horizontal, just lifting away from D, right? When a force of 225 Newton is applied vertically downwards at B, so here when you apply force downwards at B, after removing this 150, you are applying a force 225 downwards at B. It's on the point of tilting about D, so it loses contact at C. The normal reaction at C becomes 0. But initially, and they are saying the branch is modeled as non-uniform rod AB of weight W. So now before they apply this force, where could be the weight? It's a non-uniform. So it's at rest initially. On A and B, C and D, it's at rest, and it's a non-uniform rod. So non-uniform rod means there will be normal reaction on C, R1, and on D there will be normal reaction R2, the contact force. Okay, so it's a non-uniform rod means it could be the weight of it, that is the center of mass of the branch AB could be at any point. So can it be somewhere between A and C? We'll analyze it. Can the center of mass somewhere between A and C? If it is at somewhere A and C, if the weight is here, the weight of the AB, if it acts somewhere here, what will happen? Can it be at rest? Okay. If the weight is acting somewhere here, think condition for equilibrium about point C. If the weight is acting here somewhere between A and C, if the center of mass is there, is it possible? We are going to analyze it. Okay. Now think about the moment about C. When I take moment about C, the moment about R1 about C is 0 because R1 is passing through Z. So that moment will be 0. Take moment about C for R2, that will be anti-clockwise direction. Same way, the moment of W about C also anti-clockwise direction. So, in case if the center of mass of AB is somewhere between A and C, somewhere here between A and C, and when we consider moment about C, both the weight of the AB and the normal reaction both will provide moment in anti-clockwise direction, and there is no force for clockwise direction. So that means it won't be at equilibrium, but they are saying it's at equilibrium. So I can say the center of mass of AB is not somewhere between A and C. It's not here. It can't be at any point between A and C. Okay, then you can ask me, can it be somewhere between D and B? Okay, if the center of mass is somewhere D and B, the weight will act somewhere here. Then think about the normal moment about D. If I take moment about D, okay, they are saying before they apply the forces at B, up or down, whatever it is, the rod was at rest. The AB was at rest and equilibrium on the two supports. So if the center of mass is somewhere between D and D, we'll see is it possible, because it's a non-uniform rod. It can be anywhere, but is it possible to have the center of mass somewhere between D and B? We'll think about it. Okay, so we take moment about D. When we take moment about D, this will provide a clockwise moment. This moment is 0 because it's passing through D. This also will provide clockwise moment. So only two forces are acting on AB, the weight and the contact force at C. And R2 also there, but when I take moment about D, R2 won't appear there. So when I take moment about D, both W and R1 will provide clockwise moment, and there is no other force to balance the clockwise moment. That means there is no force that is anti-clockwise moment when I consider moment about D. That means the center of mass of AB cannot be between D and B. Already I showed the center of mass cannot be between A and C. So the center of mass can't be between A and C, can't be between B and D, means it should be somewhere between B, C and D. So the W is acting somewhere here. But we don't know the distance of it. That we can take the distance of W from C, let that distance be x. They are saying the distance of the point C to the center of mass of the rod is x. So they don't say it's on right of C, the center of mass. So that's the reason I did this explanation. It could be on the left of C, but it can't be. I already showed that. So this, let it be x. This distance, let it be x. Okay. Now we'll draw two separate diagrams. So here they are saying they are applying a force on B upward direction. So when the force of 150 Newton is applied on B, it's tilting about C, means R2 becomes 0. So when R2 becomes 0, take moment about C. Take moment about C. Okay, so when take moment about C means that is in this direction. You take it in anti-clockwise direction. If I take it 150 into from C to B, this is the total length is 1.5. 1.5 minus 0.24, that is 1.5 minus 0.24. The total length is 1.5. That is 150 into 1.5 minus 0.24 minus W into the length from C is x. equal to 0. Okay, so that means Wx is equal to, solve it, you will get 189. Let it be first equation. The next they are saying they are applying a force on B downward direction. So I can use the same diagram, or I can draw a diagram again. So when a force of 225 Newton is applied vertically downwards at B, so at B they are applying 225 downwards. So when it is applied at B, the branch is on a point of tilting about D. So it's going to tilt about D, means it's losing contact here. Okay, it's losing contact at C. Now take moment about D, right? We'll take moment about D. About D, if you take it. So we'll take moment about D. So in clockwise direction or anti-clockwise direction. Anyway, I'll take it this direction. So that is 225 into 225 into 0.36 minus W. Take moment about D minus W into this distance we need. This distance we needed. How much is it? Okay, so how to find that distance? That will be equal to, the whole length is 1.5. 1.5 minus 0.36, is it? Minus this length is 0.24 plus x. So W into the total length 1.5 minus 0.36. So that means 1.5 minus 0.36 from here to here. Then from that subtract this distance, that is 0.24 plus x. Okay, so that's the distance of W from D. So you will get, when you solve the left side, it will become 81 minus, so that is equal to 0. Total moment about D must be equal to 0. So 81 minus W into 0.9 minus x. Solve it inside. 0.9 minus x is equal to 0. Okay, further solve it. You will get 0.9W. 0.9W is equal to 81 plus Wx. Okay, so we can take second equation, but instead of Wx, we can get 189. So 0.9W from equation 1 and 2, if I combine, 0.9W equal to 81 plus Wx is equal to, first from the first equation, 189. Okay, so that will be 270. So find the W. So W will be equal to 300 Newton. Okay, W is equal to 300 Newton. Right, so that's the first part they asked to find. So this is all we did for the first part. Second part, they asked to find the x. So substitute now this W 300 here. So second part, I'll do it here. Second part, Wx is equal to 189. That is 300x. W is 300. 300x is equal to 189. Find x. 189 divided by 300. So 0.63 meter. That is the value of x. Okay. Okay, question number 5. This diagram is given. 3 points P, Q and R are on a horizontal road where PQR is a straight line. The point Q is between P and R with PQ equals 6x meters and QR 5x meters as shown. A vehicle moves along the road from P to Q with a constant acceleration. So P to Q, constant acceleration. The vehicle is modeled as particle. When t equals 0, the vehicle passes p with u meter per second. So when t equals 0, initially means t equals 0. When t equals 0, it's passing the point P with velocity or speed u. At t equal 12 seconds, the vehicle passes q with 2u meter per second. So here it's passing 2u meter per second at time t equal 12 seconds. So this is t equal 0, this is t equal 12 seconds. Using the model, show that x equal 3u. Okay, so we know the initial velocity. So we need to show the x in terms of u means we know the initial velocity u, we know the final velocity 2u when we consider the motion from p to q. We know the distance x, we have to give relationship between x and u, and the time is 12. So for the motion from p to q, we can use s equal u plus v by 2 into t. Without finding the acceleration, we can do it. So anyway, we can use different equations in this equation. We can use, first I'll show different methods. S equal ut plus half, s equal u plus v. That's easy. First method is a simple method. U plus v by 2 into t. So s is in terms of 6x, u is u, v is 2u, t time is 12. So simply we can find it. But if you think you want to use other equations such as v is equal ut plus half at squared, you can use it, no problem. But only thing you need to find the a in terms of the other given quantities. You can use that also. Or if you think you want to use s equal vt minus half at squared, that also you can use. Anyway, I'll try all three and show you. Method 1 is the simple one. So method 1. So this is the first part, A part. I'll put M1 for method 1. Method 1, M1 I showed it. So we use S equal U plus V by 2 into T. So S is 6x, U is U, V is 2U by 2 into, the time is 12. Solve it. It's become, so 2 into 6, 6 will get cancelled. X is equal to 3u. Very simply we can get it. But you can ask, can't we use this equation? Yes, you can, but only thing you need to find the acceleration. So method 2 I'll do. If you like to do that way, you can do that way also, no problem. So we need to find the acceleration. It's a constant acceleration. So A is going to be change in velocity 2u minus u over time taken is 12. So it's going to be u over 12. Then use s equal ut plus half at squared. So s is 6x, u is u, time is 12 plus half into acceleration u over 12, t squared 144, 12 squared 144. Solve it, you will get the final answer. So it's going to be 2, so 24, 12, so 6u, so 6x is equal to 12u plus half, this is 12, so 6u. So that is, you can divide whole equation by 6, is going to be x is equal to here 2u plus u 3u. You can get it. Okay, method 3, can't we use s equal vt minus half at squared? Yes, you can use. So the equation meaning means, this equation careful, that means at time t, it's moving for time duration t. During the time t, during the time t of motion, the final speed at time t is v. So acceleration is a. The distance traveled during that time is s. That's the way we use the equation. So method 3, M3 I put it, s equal vt minus half at squared. A I already found it here, I used that same A, but if you are using it, we have to use from the beginning. If you are using it, you have to find A, but I use this same A. S is 6x. The final speed is 2u. Time is 12 minus half into A is u by 12, but I found here, into t square 144. So that's going to be 6x equal to 24u minus here 12, 6u. Okay, you can see this is 24 minus 6 is 18, 6x equal 18u, x equal 3u. So whatever the method you follow, you'll get the answer. Okay, so the same question, part B. As the vehicle passes Q, the acceleration of the vehicle changes instantaneously to 1.5 meter per second. So for the motion from P to Q, we don't know the acceleration, but we know it's a constant acceleration. But from Q onwards towards R, the acceleration becoming another constant, which is 1.5 meter per second square. So during the motion from Q to R, the acceleration is 1.5 meter per second squared. And it passes R with the velocity. So when it reaches the R, the velocity becomes 3u. Okay, the speed becomes 3u. Using the model, find the value of u. So here also we can do different methods. Two methods I'll show that. Okay, so first method, B part, method 1, M1 I put, that's for the method part. Method 1, we know we have another equation, that is v squared equal u squared plus 2as. That's also one of the well-known equations of motion. If I use that one, that will be easier. So for the motion from Q to R, Q to R, if I consider, the R is the final point where the velocity is 3u. So I'm going to use v squared equal u squared plus 2as from motion Q to R. V squared, that is 3u all in square. Initial velocity is 2u all in square plus 2 times acceleration given 1.5 into distance traveled is 5x. Directly we will get relationship between u and x. We already found it, u equal 3x, so we can solve by using this way. Okay, so solve this one, you will get 9u squared equal 4u squared plus 2 into 3, that is 2 into 1.5, 3 into 5, 15x, but we already showed in the first part x equal, we already showed that x equal 3u, we already showed it in the first part. So this is 2 into 1.5, 3 into 5, 15, 15x, 15x means 15 into 3u. Okay, solve this one further. So you'll get 9u squared minus 4u squared, it's going to be 5u squared is equal to 45 u. Divide both sides by u because u is not equal to 0. So 5u equal 5u equal 45. So u equal 9 meter per second. So they are giving u meter per second, means u is 9. Okay, that's the method 1. Okay, what could be the method 2? Method 2 means we know the acceleration. So acceleration equal v minus u over t. We know that. For the motion q to r, acceleration 1.5, that is 3 by 2. 1.5 minus 3 by 2, easy to handle with fraction. 3 by 2 is equal to. For q to r, R is the final point where the velocity is 3u. Q is the initial point where velocity 2u over t. I am going to find the time. So solve it. So solve it. You will get t will be equal to 3u minus 2u, that is u equal u over t equal 3 by 2. So the t will become 2u by 3. T will be 2u by 3. Now use the equation S equal u plus v by 2 into t for the motion q to r. Same thing. So S is 5x. Initial velocity is 2u, that is at q. Final velocity is 3u at r over 2 into time is 2u over 3. Okay, so 5x, we know x equal 3u, x equal 3u. So if I substitute x equal 3u, it's going to be 15u here. So 2 plus 3, 5u over 2 into 2u over 3. Okay, so here 15u, 5u, so when they get cancelled it become 3 here. So 2 and 2 get cancelled, q by 3. From this u is equal to 9. Anyway, you'll get the same answer. Whatever the method equation you use, the answer will be the same. Okay, now part C. Question number 5, part C. Find the distance traveled. Now they are saying find the distance traveled by the vehicle during the first 14 seconds. First 14 seconds after passing P. So after passing P, what's the distance traveled during the first 14 seconds? Careful. Because 14 seconds means up to 12 seconds. First 12 seconds after passing P, it has an acceleration, separate acceleration. Then beyond it, the acceleration is 1.5. So they are asking after passing P during the time 14 seconds means that must be considered as 12 seconds a particular acceleration, then the next 2 seconds 1.5 meter per second squared. Careful, because during the after passing P, the first 12 seconds it's traveling with one particular acceleration. During that time it travels a distance 6x meters. Then after passing Q, it has separate acceleration. So it's going to travel 2 seconds after passing Q, because the question is what's the distance traveled after passing P during first 14 seconds. Careful. Sometimes if you use the whole motion as 1, if you treat it, you might go wrong because acceleration will be different beyond Q. Okay, during first 12 seconds, it travels P to Q. So the distance P to Q, we'll find it. PQ, that is 5x meters. So 5 into x is 3u, 5 into 3u. So that is 5 into 3 into u, we found it, that is 9. This much of meters. 5x meters. So solve this one. You will get a distance traveled during the first 12 seconds when it moves from P to Q. That will be equal to 162 meters. Okay, now 2 seconds remaining. That is 14 seconds there. 2 seconds remaining after passing Q. So for the from Q onwards, from Q, next 2 seconds, if I say the distance travel is d, I am going to use the equation s equal ut plus half at square. That is d is equal to the initial speed at Q is 2u. 2u into 2 plus half acceleration 1.5 2 square. Okay, we'll find the d or d1, whatever it is. So d1 is going to be 2u into 2, that is 4u. 4 into u is 9. 4u, u is 9. Plus half into 1.5 into 4. How much is it? Solve it. (39 meters). So distance traveled during 14 seconds after passing P, that is going to be 162 meters plus 39 meters. That will be 201 meters. Okay. Okay, question number 6. This diagram is given. A boat is pulled along a river at a constant speed by 2 ropes. Constant speed means acceleration 0. Acceleration 0 means resultant force in any direction must be equal to 0. So the bank of the river are parallel and the boat travels horizontally in a straight line parallel to the river bank. So the boat is traveling parallel to the river bank at constant speed. Constant speed means the direction of resultant force in any direction, the total resultant of the force in any direction must be equal to 0, and it's moving along the horizontal direction. Means when you resolve all these forces vertically, the resultant force must be 0. When you resolve horizontally also, it must be equal to 0 because it's moving at constant speed, constant velocity, acceleration equal to 0. The tension in the first rope is 500 Newton and the angle is 40 degree with the direction of velocity. The second has a tension P Newton that makes an angle alpha. The resistance to the motion of the boat as it moves through the water is constant force of magnitude 900 Newton. So if I show this as a particle, they are treating this boat as a particle. If I draw it as a particle, this is the direction of motion. There is a resistive force. That resistive force is given 900 Newton. Because resistive force is horizontal, because boat is moving horizontal, always the resistive force will be opposite to the direction of motion. So it's moving horizontally parallel to the river bank, means the resultant force, or sorry, the drag force or the resistive force will be opposite to the velocity. Velocity is parallel to the river bank. River bank is horizontal, so velocity is along this way, means the resistive force will be on the same line, opposite direction. So the 500 Newton is along this direction. So the P Newton is this direction. This is 40 degree. So that makes an angle alpha. Right. The boat is modeled as particle. The ropes are modeled as being light and lying in a horizontal plane because ropes have no mass, so the acceleration will be considered. Anyway, the ropes, they are light means their mass is 0. That's enough for you. Yeah. The value of alpha and value of P, we had to find it. Okay, so resultant force is 0 in any direction. We had to resolve the given three forces, any direction. Normally we resolve horizontally and vertically. Horizontally the resultant force must be 0 because no acceleration, it's moving at constant speed. Vertically also should be equal to 0. So when I resolve vertically first, this direction, if I find the resultant force, this has no vertical component because already it's horizontal. When you resolve a vector through 90 degree, horizontal, vertical, 90 degree. So horizontal vector has no vertical component. When you resolve this vertically, 500 sine 40 minus P sine alpha equal to 0. So P sine alpha equal to 500 sine 40. Right. So that is P sine alpha. If you solve it, P sine alpha equal to 321.4. Let it be first equation. Okay, we'll resolve it horizontally. That also the resultant force 0. That is 500 cos alpha plus 500 cos 40. 500 cos 40 plus P cos alpha minus 900 equal to 0. So solve it. P cos alpha, take this right, take this also right. P cos alpha will be equal to 517. Second equation. Okay, divide first equation by the second equation. P sin alpha over P cos alpha is equal to 321.4 over 517. P and P will get cancelled. Sin alpha cos alpha tan alpha equal to 321.4 divided by 517, 0.622. So find the alpha, you will get 31.9, that is 32 degree. Okay, that's the value of alpha. So that's the first part they asked to find. So that's the value of alpha. Second part, they asked to find the P. Substitute this value of alpha in one of the equations, you will get it. So first, if I use the first equation, P sine 32 is equal to 321.4. If you want, you can substitute in here. Anyway, you will get the same answer. So P will be equal to 608.2. If you want to give it in 2SF, that will be 610 Newton. Okay. If you want, you can use Lami's theorem, but this is easy. Okay, question number 7. This diagram is given. A simple lift operates by means of a vertical cable which is attached to the top of the lift. The lift has mass M. So the lift has mass M means there will be weight due to the lift cage that will act vertically downward from the center of mass of the lift. So that we don't know where I say it. So we'll just put the weight downwards, mg. Right. The box Q is placed on the floor of the lift. A box P is placed directly on top of Q as shown figure 4. The cable is modeled as being light and inextensible and air resistance modeled as negligible. The tension in the cable is of 42 mg over T. So that's the tension in the cable T, that is equal to 42 mg over 5. That's a tension. Okay, so the first part, the acceleration of the lift and its contents move vertically upwards with acceleration 2g over 5. So it's accelerating upwards. A is equal to 2g over 5. Using the model, find in terms of M is the mass of the lift cage, combined mass of P and Q. So the combined mass of P and Q, if I say the combined mass of that is mass of P plus mass of Q, if I say that as M combined C. So that due to that there will be weight acting downwards. That weight we can take it as mcg. The weight due to the combined mass of it, we can take the downwards mcg. This is mg is the weight of the lift cage. Okay, we need to find the value of mc in terms of m. That's all. So it's moving, accelerating upward direction. So we consider the whole system. There are forces. How many forces acting? Tension, upward direction. Total weight of P and Q downward, mcg. The weight of the lift cage, mg. The mass of the system is mc plus m. Okay, we'll use first part. That is, we need to find the mc in terms of m. So, 8 part. We can use F equal ma upward direction for the system, for the whole system. So the total force is upward tension T minus the weight mcg minus mg equal to total mass mc plus m times the acceleration a, that is 2g over 5, or I'll put mc a is 2g over 5, I want to substitute. So tension we know that 42 mg over 5 minus mc plus m g, I take it out, mc plus mg, I take the g out, is equal to mc plus m instead of acceleration 2g over 5. Okay, from all their equations we can cancel g good can cancel. So that will be 42 m over 5 minus mc minus m equal to mc into 2g over, so g got cancelled, 2 over 5 or 2mc over 5 plus 2m over 5. So I need to find the mc in terms of m. Rearrange it. So that will become 42m over 5 minus m minus 2m over 5 is equal to 2 mc over 5 plus mc. So that will be 5m, 7m, 42 minus 7m, 35 m over 5. So that's going to be 35 divided by 5, that's going to be 7. 7m is equal to 7m is equal to here 5 plus 2 7 mc over 5. 7 get cancelled, cross multiply, so mc equal to 5m. So the total mass will be equal to 5m. Total mass of P and Q is equal to 5 times the mass of the lift. Okay, so the next part, that is part B. During the motion of the lift, the force exerted on P by Q is 14 mg. So if you draw the proper forces acting on it, so if I think about the Q, the force Q, sorry, the object Q, the V part, this is Q. So the weight of the Q will act on Q. Normally students, they make mistake. When I sit on a chair, my weight will act on the chair is a wrong statement. My weight will act on me because earth is pulling me. Pulled by earth is the weight, right? So the contact force exerted by me on the chair is the contact force, right? So here the weight of the Q will act on Q. So I can say the weight of the Q, which is downwards, that is mqg. We don't know the value, mqg. Right. So it's resting on the lift. So it will exert of contact force on the lift. It pushes the lift down. So the lift will push it up with the force R1. Force R1. The third law pair of this will act on the flow of the lift. Q pushes the lift down. So lift will push the Q up. Also, P is kept on Q. So when I draw the free body force diagram for P, this is the P. P has its own weight which is acting downward direction, that is mpg. The weight of P will act on P. The P is resting on Q. So P will exert a force on Q, the contact force on Q. That force, if I say R2, that's a force exerted by P on Q, that is R2 this way, means Q will exert force, same force on P upward direction here, where it's touching, that will exert a force on P according to Newton's third law. P will exert force or push on Q, that is R2. So Q will exert the same magnitude of force on P according to Newton's third law, that is R2. That is R2. Right. Now, when the lift accelerates, when the lift cage accelerates upward, everything inside the lift also should have the same acceleration. Otherwise, if when you are moving inside lift, if the acceleration of the lift is different from acceleration of your body, you might break the lift and come out. Every moment the velocity should be the same way change. Your body, what the rate of change of velocity should be same as the rate of change of velocity of the lift cage. Otherwise you will break the lift and come out. So when the lift accelerates upward at 2g over 5, P is accelerating up at the same value, Q also accelerating up at the same value. All of them, both P and Q, they all are accelerating upwards with the same acceleration, which is 2g over 5. Okay, the R2, the force exerted by Q on P, R2, they are third law pair of forces. P is exerting force on Q, Q is exerting force on P, the contact force. R2 is given, that is R2 is equal to 14 mg over 5. 14 mg over 5. Right. The question is, find in terms of m, the mass of p. So we know the combined mass we know, but they have to find the mass of p, right? So I'm going to use for p upward, because I told p also accelerating upward same as the lift cage. Q also accelerating at the same as the lift cage, otherwise you will break and come out of the lift. So for p I'm going to write upward direction F equal ma for p. So I need to find the resultant force acting on P. What are the forces acting on P? There are two forces. One is its weight mvg, the mass is mv, and also R2, the force exerted by Q on P, the contact force. So that is R2 is the resultant force upward, sorry, that's the force upwards. MPG is downwards, it's accelerating up, means R2 must be greater than MPG, because then only the resultant force of R2 and MPG will be upward, then only it can have the same acceleration as the lift. So if the lift is accelerating upwards, P also accelerating upwards, means P should have a resultant force upwards. So R2 must be greater than MPG. R2 minus MPG equal to MPA. F equal ma. So R2 is given how much? 14 mg over 5 minus mpg equal mp times acceleration is given 2g over 5. Solve it. All the g will get cancelled. So 14 m over 5 minus mp equal to 2 mp over 5. So when I continue this on here, 14 m over 5 equal to, take it to the other side, so it will become 2 mp over 5 plus mp, that is 5 mp plus 2 mp, 7 mp over 5. So mp is equal to 5, I get cancelled, 7 into 2, mp is equal to a mass of P is twice the mass of lift. So mass of Q, if they ask, mp plus mc is 5. So mp is 2, means mq will be 3 times mass. So this is the answer. They are not asking anything about the mass of the Q. They ask only the mass of P, that is 2 times the mass of the lift. That's the answer. Okay, question 8 about motion or equilibrium on an inclined plane. So that you must know theory on an inclined plane. If slopes makes an angle alpha, if there is an object kept, a small object if I draw, the weight will act vertically downwards, that is mg. This is 90 degree, this will be 90 minus alpha. The component of the weight along the plane down will be mg cos 90 minus alpha. This is 90 minus alpha. So cos 90 minus alpha, mg sin alpha is the component of the weight along the plane down. Component of the weight perpendicular to the slope will be mg sin 90 minus alpha, that is mg cos alpha. So I resolved those two forces, so I don't need to show them, right? So the weight is resolved into two right angle directions. So the normal reaction will be along this direction. If the object is moving along the plane up or down, there is no motion perpendicular to the plane. So perpendicular to the plane, the resultant force must be equal to 0. If I consider perpendicular to the plane in this direction, the resultant force must be 0, means the normal reaction should be equal to mg cos alpha. The friction, the equilibrium at the limiting friction Fr maximum, the limiting friction is equal to mu r. So that will be given as mu into mg cos alpha. If the object is trying to slip down, the limiting friction will act upward direction along the slope. If it is pulled upwards by using a force and it's at equilibrium, gradually increase the force. At a limiting equilibrium, it will try to slip upwards, means the friction will act downwards, that also mu mg cos alpha. If the force is removed, if it is trying to slip down, there the limiting friction will be upward, mu mg cos alpha. Remember that. Normally, it's a normal theory. Okay, question number 8. This diagram is given. A parcel of mass 2 kg is pulled up rough inclined plane by the action of constant force. The force has a magnitude of 18 Newton and acts at an angle 40 to the plane. The line of action of the force lies in a vertical plane containing a line of greatest slope of the inclined plane. The plane is inclined at an angle 30 degree to the horizontal. The coefficient of friction between the plane and the parcel is 0.3. So mu is 0.3. Right. The parcel is modeled as particle P. Find the acceleration of P. So we'll consider the forces acting along the plane down. So that's the A part. I already explained how to draw, how to show the forces. If I draw the parcel alone, or if I draw again separately. So the force acting at an angle alpha at an angle 40 degree is 18 Newton at an angle 40 degree. So what are the other forces acting? Along the plane down, there will be the component of the weight mg sine 30. So the friction will act along the slope down, that is mg, the limiting friction means mu r. So the normal reaction will act along this way, that is r, that is equal to mg cos 30. I explained already the component of the weight along this way is mg cos 30. So there is no motion perpendicular to the slope, so the normal reaction should be equal to mg cos 30. Okay, so these are the only forces acting on it. We'll consider the Newton's second law along the plane up. So before we need to find the normal reaction, so that is mg cos 30, and also there will be sorry, I made a mistake, because there is mg cos 30 and this is also there. So we'll put the r, sorry, this is the weight, component of the weight. So there will be normal reaction r. Okay, right. So it won't be mg cos 40 because there is a force. It also has a vertical component. So r plus 18 cos 40 equal mg cos 30. Okay, if this force is not there, r equal mg cos 40, but here r plus 18 sin 40 equal to mg cos 30. Because when I resolve this 18 along this direction, there will be a component. So in this direction there is no motion, no acceleration, means in this direction resultant force must be 0. R plus 18 sin 40 equal mg cos 30. So if I resolve along perpendicular to the slope, R plus 18 sin 40 minus mg cos 30 equal to 0. So we have to find the r for the mu r. So first we'll find the r. Okay, so that is r is going to be mg cos 30 minus 18 sin 40. So mass is given 2 kilogram, 2 into 9.81 cos 30 minus 18 sin 40. So R will be equal to 5.42 Newton. So that's R. If the 18 is not there, R equal mg cos 30. Okay, so since due to the 18 Newton, the R will be different. Right. We have to resolve all the forces perpendicular to the slope and equal to 0 because there is no acceleration perpendicular to the slope. Right. Okay. Now we'll consider along the plane up the Newton's second law. Along the plane up, F equal ma at an angle 30 degree. What are the forces acting along the plane up? 18 cos 40. 18 cos 40 is component along the plane up. Then minus the component of the weight, minus mg sin 40 minus friction mu r equal to ma. We'll substitute m2. We have to find the acceleration. Okay, so that's going to be 18 cos 40 minus 2 into 9.8 sine 40 minus mu is given 0.3 times r, we found it 5.42, equal m is 2 times a. Everything we know, only thing unknown is a, we need to find the a. So a will be equal to 1.18 meter per second. So that's the first part answer. The first part they asked, A part, find the acceleration of P. Okay, so B part, the points A and B lie on a line of greatest slope of the plane where A be 5 meter and B is above A. So there are 2 points on the slope. Maybe this is A, this is B. Okay. So it was okay, we can put A, B somewhere here, this is A, we'll put it here, this is A, B is somewhere above it, so B is somewhere above it, somewhere here the B, the point B, right, along the slope. The distance between A and B is 5 meters, so this length is 5 meters, it's given in the question paper, right. So, and B is above A. P passes through A with a speed of 2 meter per second. So at A, the speed is 2 meter per second. So here the speed is 2 meter per second along the slope up. The question is, find the speed of P as it passes through B. Okay, so we know the acceleration. So B part, we can use S equal ut plus half at squared. Oh, sorry, we can use time we don't know, so we'll use v squared equal u squared plus 2as. For the motion, A to B. Okay, we know the final speed, we need to find it. A is the initial speed, where the speed is 2 meters. 2 squared plus 2 into acceleration 1.18. The distance AB, that is 5, solve it and find V, 3.97 meter per second. Okay, so the part C, the force of 80 Newton is removed at the instant P passes through B. So we'll see this is the point B. Again, just I'm using the earlier diagram. So when it passes through the point B, the force 80 Newton is removed. So this force is removed now. So the only two forces acting on it. What are the forces acting on it? The weight acting down, its component along the slope is mg sine 30, perpendicular slope is mg cos 30, and then there is a normal reaction R. Okay, so there is no force to pull it upward direction. There is no force to balance this the component of the weight, but there could be the friction. Now the friction won't act downward direction because the weight, the component of the weight is acting downward direction. So the friction, if it balances the mg sine 30, it could be at rest. But if the friction, the limiting friction, the maximum friction, which is mu r, the limiting friction, if it is smaller than mg sine 30, then it will accelerate down. So the question says, determine whether P will remain at rest at C. You must show all stages of your working clearly. So force 80 Newton is removed at point P, passes through B. As a result, P comes to rest at point C. So it moves and coming to point C, and this is the point C where it's coming to rest. Okay, when it comes to, because it's going to decelerate, it's going to decelerate after 18 Newton is removed. When it moves up due to the velocity it gained from A to B, we found the velocity at B, that is 3.97. So when it reaches that point, if you remove the force 80 Newton, it will move further up, decelerate. Because why does it decelerate? The component of the weight is acting down. During that motion, yes, it's moving up, so the friction also will act upward direction. Until it comes to rest, the friction will act along the slope down. Now it has come to rest at point C. Will it remain at rest at point C, no motion, right? It has come to rest. So when it comes to rest, will it continue to be at rest means the forces acting on it, the component of the weight along the slope down, and there must be friction acting upward direction because uh, if it slip down, the friction will act up, or if it try to slip down, also the friction will act up. So the friction force is equal to mu r at limiting friction. Otherwise, there will be a friction. It can balance the component of the weight mg sine 30. So we will find, the question is, will it remain at rest? If it wants to remain at rest, the component of the weight mg sine 30 should be balanced by the friction. Say for example, I am going to find the limiting friction. Limiting friction means the maximum friction that could be applied to the box depending on the contact surface of the box and the slope. The limiting friction is given by part C, Fr maximum, that's a limiting friction, is equal to mu r. If this limiting friction is greater than the component of the weight mg sine 30 means it will be at rest. Because for example, if the limiting friction becomes 5 Newton, the component of the weight, I am example saying component of the weight is 3 Newton means this is the maximum friction. There will be a friction which is 3 Newton can balance this 3 Newton. But if the limiting friction is 5 Newton and the component of the weight is 6 Newton, the friction can't act more than this. So the component of the weight is more than the maximum friction that could be applied. So it will certainly accelerate down. So here what should I find? They are not asking to calculate anything. Determine whether P will remain at rest at C. So we will find the limiting friction. What could be the maximum friction applied on the box at the point C? If that limiting friction is greater than mg sine 30, then there could be a friction which is equal to mg cos 30, mg sine 30, and it can keep it at rest, right? So we'll find the limiting friction. So Fr max equal mu r, but r is equal to, here there is only one component of force, mg cos 30. So Fr maximum equal mu mg cos 30. So that is 0.3 2 into 9.8 cos 30. So this is the maximum friction that could be applied on the parcel or box. So that will be equal to 5.09. So the friction can't be more than this. We'll find the component of the weight along the slope. That is equal to mg sine 30, 2 into 9.8 sine 30. So that will be equal to 9.8 Newton. Yes. Now you can see the component of the weight along the slope down is this much. The friction, maximum friction that could act on the box is 5.09. The maximum friction is smaller than this. So the friction can't balance this component of the weight. So it will not at rest, it will accelerate downwards. So since 9.8 Newton greater than Fr maximum, that is 5.09, there will be resultant force along the slope down. So parcel will not stay at rest, or P will not stay at rest at see, it won't stay at rest because it will accelerate down. In case if this Fr max, in case if the compound of the weight something like 4.2, for example, depending on the mass, if it becomes 4.2 means maximum friction 5.9, this is 4.2 means it can apply a friction 4.2 and keep it at rest. But the compound of the weight is more than the maximum, possibly maximum friction, so there is no way to balance it, so it will accelerate down and it won't be at rest. Okay, so that's all this question. See the description of this video, the timestamp is given. Also, by using the playlist of this channel, you can navigate to any video related to physics 1, 2, 3, 4, 5, 6, and also you can navigate to mechanics M1, M2, M3, any lessons, any videos you want. Okay.